So now we're going to start talking about the Ethernet library, the library that's used to control an Ethernet controller, an Ethernet shield. So we'll start with the hash include. So at the top, like with all these libraries, you need a set of hash includes to include a bunch of header files, .h files. There are a lot. So for instance, Ethernet.h, Ethernet client.h, Ethernet server.h, and there are several more. The easy way to do this in your sketch is just to go to the IDE, go to sketch, import library, Ethernet, and it'll just stick in all the hash includes that you need for the Ethernet library. So let's assume you do that. Then there are several functions provided to initialize the Ethernet interface, right? To initialize the shield. So these are the first things you're going to call when you want to use the shield. So Ethernet begin, that's really the function, right? Which is a common name for the first function in any library, but Ethernet begin, you call that function. Now there are 5 possible arguments for Ethernet begin. Only the first one is required, and the rest are optional. We'll go through all of them, and we won't actually use all of them. The first one we have to give, the rest we probably won't. But let's go through all of them. So first argument that is required is the MAC address. That's the MAC address of your Ethernet shield, which you can make up, by the way. In most shields, you can just create whichever one you want to create. You can use that. Or if it has a sticker on there that indicates its MAC address, you can use that too. IP address, that's the IP address of your shield, optional. DNS, so that's the IP address of the domain name server that you want to connect to by default, and you don't have to give that. Gateway is the address of a router which knows how to route packets to other networks. So if you're going outside of your local network, which we won't in this class, but if you are, then you might want to specify a default gateway, a default router to go to. When it wants to send packets to an outside network, it can go ask this gateway router for the path to say, how do I get this there? Now, if you don't give a gateway, it'll find a gateway, but sometimes you want to have a particular service will have its own gateway to speed things up, but you don't have to do that. Also, the subnet mask. Subnet mask tells this which other IP addresses are in the local subnet. So this is sort of a flexible idea, but a subnet you can think of as your local network, right? And generally what happens is with the IP addresses, the prefix, so it's a 4-byte number, right? 4 numbers separated by decimals. And the higher bytes, the most significant bytes, are often held constant for all the machines in a local subnet, right? So in a local subnet, maybe it's 128, 198, 200 are the first 3 numbers, and then the last number is a 1 for my machine, a 2 for the next machine, a 3 for the next machine, and so on. But they share, in that case, local subnet shares the high 3 bytes. So the subnet mask tells you which bits are shared by the local subnet. You don't have to specify this. If you don't, it'll default to 255, 255, 255, 0. So what that means is, remember, 255 in binary is all 1s. So all 1s, all 1s, all 1s, and then all 0s. So that's saying that the local subnet is just the last byte. So all the nodes in the local subnet share the same high 3 bytes. That's what it says, and that'll be the default if you don't set it, but you don't have to. Okay, Dynamic Host Connection Protocol. So this is pretty important, or DHCP. So in order to communicate on the internet, you need an IP address. Okay, every node on the internet needs an IP address. Now note that in our Ethernet.begin, we did not have to specify an IP address. So how is it going to communicate on the internet without an IP address? Well, it has to get one. It can get one dynamically. So DHCP, Dynamic Host Connection Protocol, is a protocol that allows a new node on the network to request a new IP address. Now, this is generally enabled on routers by default. So for instance, right here, right now, my laptop is sitting over there, and I opened it up. And when I opened it up, it connected to the local network at school, and it uses DHCP. And the local network is set up for DHCP. That's turned on. And my machine, basically, in order to communicate, the first thing it does is it asks, through using this DHCP protocol, it asks for an IP address. So it gets its IP address dynamically from the network. And the network finds some available IP address and tells my machine, OK, here's your IP address. So that's what we're assuming is being used. And it's very common. So let's assume that that's being used, and that's why we don't have to specify an IP address. We can just assume that DHCP is being used to give us an IP address. Now, DHCP is invoked if you call ethernet.begin and it has no IP address argument. So if you just if you call it with a MAC address argument and nothing else, no IP address, no anything, then it automatically invokes DHCP, making a request. You don't have to deal with these details, but your Ethernet shield will make a request to the local network to ask for an IP address after you call begin. Most routers are configured for DHCP. Now, another way to do this, instead of allowing DHCP, which gives dynamic IP addresses, you can also use static IP addresses. Static IP addresses are fixed IP addresses, so that means every time you power on your machine and connect to the network, it gets exactly the same IP address. Okay? Now, a static IP address, it's more difficult to manage. Basically, that IP address needs to be known across the world, right? It has to be known, so any machine that wants to connect to your machine, it needs to know that static IP address. It's useful for servers. It's typical for servers because say www.uci.edu. There's a web server right there, which I can go to. And in order for my laptop to connect to that server to look at the school's web page, I need to be able to look up its IP address. So it needs to be static. It needs to sit in the same place and be in a table somewhere. So when I request this address, I can get it. So servers often have static addresses, but dynamic addresses are very common for non-servers. Thank you.